Okay, rational functions. A couple of these just have pictures, so it's a good place to start. Remember, if we're doing vertical, horizontal asymptotes, we're writing equations of lines. So that's the biggest thing to remember. Now you're going to be choosing these, but remember, if you're writing a vertical, it's x equals, because you're going through the x-axis. If you're doing a horizontal, it's y equals, because you're going through the y-axis. Or that's how I remember it, at least. Here on number 1A, our vertical asymptotes go through the x-axis at x equals -2 and x equals 2. And our horizontal asymptote here is at y equals 1. Done and done. Just identifying those from the picture. On part B, we have a vertical asymptote. It's a little easier to see here in color. We're going through the y-axis, or through the x-axis at x equals 0. So our vertical asymptote here is x equals 0. Here we have an oblique asymptote, or slant asymptote, whichever you want to call it. They mean the same. Our oblique asymptote goes through 0, 0. So if we're thinking y equals mx plus b, our b is 0. And our slope here, we're going up 2 over 1. So if you want to think about that slope, rise over run, so our slope is 2. So our oblique asymptote equation is 2x, or 2x plus 0. Now let's look at one where we have to do a little bit of work. Here we're doing domain and range, as well as intercepts and our asymptotes. The first thing I do is factor. Always factor everything. You can lean on your calculator as much as you want. So if you would like to just go and look at that on your calculator to start, that's great. I always put in the original equation. Having a minus in there would be key. Now remember, your calculator has a pixel situation. It just isn't small enough. Your pixels aren't small enough to show you kind of everything sometimes. So here's our picture. What this is showing us isn't that this equation, that our function really stops. It's showing us that the pixels aren't small enough to get any closer to these lines without touching them. And your calculator isn't going to do something that misleads you. So we have two vertical asymptotes. We're going to have a horizontal asymptote here. This is a funky one because we are going to cross a horizontal asymptote there. But you guys remember from the unit, horizontal asymptotes are crossable at distinct values, but we never cross a vertical. You can pretend like those lines are straight. Okay, let's start to talk about our key information. Let's just go through the list. Intercepts. Here we're talking x-intercept and y-intercept. You can get that from your table. So if I go to my table, I suspect that it's 0, 0 from the graph, but let's make sure we actually have that value there. 0, 0. So our x-intercept is 0, 0. Our y-intercept is 0, 0. Intercepts, done. Removable discontinuities, nothing for this problem, nothing cancels, so we don't have anything in your removable discontinuities. We have vertical asymptotes. We can see them on our graph, but also from our equation. Our vertical asymptotes are at -5, x equals -5, and x equals 5. Since this is a bottom-heavy fraction, our horizontal asymptote is y equals 0. You, of course, can see all of this from the graph, but it's nice to see it in the equation as well. Your x-intercept comes from setting the top equal to 0. So, oh hey, x equals 0. If x equals 0 is your x-intercept, then it's your y-intercept as well. Okay, so we did asymptotes. Remember, we're going to have a horizontal and vertical, or a vertical and oblique, but we're not going to have a horizontal and oblique together. For domain, we are going to exclude our asymptotes. You could see domain in either interval notation or step builder notation. So we're just excluding those asymptotes at 5 and negative 5. I'll do it in both notations for you. Whew. And we also want for range, for range, because of this middle guy here, our range is all reals. I need to fix my key on that one because I excluded 0. Oh, yeah, I did exclude 0 on my keys, so I will have to fix that. All right, that's 1, 2, and 3.